So two problems. One is that I don't speak Spanish. I apologize for that. It was a surprise for me. And the second thing is that I will talk about classrooms more than about virtual learning. But maybe in the introduction I make a big the link between two of them. By the way, yes, I have a PhD in computer science, but I am a primary school teacher. I was a primary school teacher 30 years ago in Belgium, actually, and I'm still a primary school teacher. In my university, which is a top science university, there are no primary school teachers, so I'm proud to be that. So let me tell you why we come to this. Let me tell you why we come to this idea of classrooms and the role of the teacher. So to make a long story very short, okay, what we know from studies on collaborative learning, it works. In about, if you take about 1,500 studies and 2/3, yes, learning in teams is more effective than learning alone. That's good for a politician. But for scientists, it means no, it is not more effective. It is sometimes more effective. And the question is, when does it more effective? So it is more effective if the guys, the team members, the guys, the women, start to engage into rich interaction, like they disagree, they fight, or they misunderstand, they explain to each other, or they regulate each other. Then, if this is a kind of rich interaction in the team, then you will have positive outcomes. The problem is that it's not always like that. So for this reason, we invented some kind of scripts. There are kind of pedagogical methods to have more chance than people disagree, to have more chance that people explain. For instance, if you give a jigsaw method, like people receive different information. In the team members do not receive the same information, so they have to explain to each other. That's the only way to solve the problem. Or you give them conflicting information, so they will disagree. They will, that's for the video record. They will misunderstand, they will fight. So this called script, I will show you a script. And then the script, progressively, they became not about collaboration, but more global. It's not only about teamwork. In the same method, there is sometimes individual learning, the child is alone, and sometimes the whole class with a teacher. Okay? So we have this pedagogical scenario that includes individual activities, team activities, and class activities. Okay, that's very nice, because collaboration should not be a religion. You know, we should not say, oh, everything should be collaborative. No, sometimes it's good to be alone, to read, to summarize, to write. Sometimes it's good to be alone. Sometimes it's good to be with a teacher. So it's not only collaborative. It's collaborative as a part of something which is more complex. And the problem is that sometimes it's too complex for the teacher. It's not easy. We invent methods which are difficult. Okay, now you work individually, and then you make teams, and then I give my lecture. That's only for super teachers, you know. And we don't want to invent methods that works only for super teachers. We want to invent method that works for the normal teachers. So the question is, can we design technology? That's my question today. Can we design things which are easy to use? I will show you one of them today. Things which are easy to use, that which there is no Control-Alt-Tab, there is no login, there is no password, and all these bloody things. So that's the idea. So if I summarize the history of collaborative learning, there has been a first, let's say, 20 years where people say, okay, how can we design collaboration? It's not natural collaboration. It just, the teacher should not just tell to the guys, hey, work together. That does not work. You have to organize, to give roles, phase, deliverables, and so on. And then in the second phase came the idea that, well, it's not only designing the pedagogy, we have to design everything. Like this login, you know, when the kids connect to the system, they have to log in. If you are teachers, you know that's terrible, because some of them forget the password, or the caps lock key which is down. You lose 5 minutes. 5 minutes, this is 10% of lesson time. Why do you waste 10% of the lesson time for login? Because some stupid computer scientist in the school said all the kids must log in. What is do we get 10% added value? That's the kind of problem we discussed today. So let me start with a very concrete story. It's about vocational education. In Switzerland, 2/3 of the teenagers, when they are 16, they leave school, they go to vocational training. They learn a job at 16, okay? 20% go to university, okay? And that's for losers. The real men, they learn a job when they are 16, okay? And 4 days per week in a company, 1 day per week at school. That's the basic of the Swiss economy. Every plumber has 4 years or 3 years of training in economics, in German, French, English, and so on, and mathematics. So that's the basic of kind of quality of life in Switzerland. Okay, so we went to visit these apprentices. They are called logistics assistant. They work in a warehouse and they drive a forklift, you know, this transpalette. And we tried to see what they learn in the warehouse. So we went to interview 10 of them in a company, and we followed them during 1 day. We talked to them, to the boss, and so on. And what do they learn? Not a lot, honestly. That's the basic of the idea. They will learn very concrete skill in the company, and in school they will reflect and elaborate the theory behind these skills. They don't learn much. They move boxes as fast as possible. You know, the boss wants them to be fast, not to think about logistics. So they're supposed to learn logistics. But then at school, they have a course of logistics. You know, but it doesn't mean anything for them. So logistics means, for instance, that if you have a product that you sell every day, you put the product very close to the place where the trucks arrive and leave. If there is a product that you sell once per month, you put it on the back of the warehouse. They have to learn this kind of mathematical reasoning. But these guys, you know, they are not schoolish students. You know, they always fail everything at school, and they have to learn logistics, which is like mathematics. So, can we teach logistics in a more concrete way? So we came with these tags. You know, all of you know these tags that we put on shelves. On the top of it, there is a camera that will recognize these symbols and beam information. There is a beamer there and a mirror that will project information. And this is something they put on the desk in the classroom, and for which the teacher set up different activities. So I will show you quickly how it looks like. So they will put shelves. First, the activity is set up by a sheet of paper, and there the warehouse, this is where the trucks arrive and leave. And here, you see, tack, it becomes red because the forklift can pass but cannot turn. No, it's okay. So they do logistics, but concretely with plastic shelves. Once they are ready, they can run the simulation and see the warehouse they've created. Here on the left, the system displays things like the performance, the quality, how many seconds to move a box from the shelf to the truck. And then there is here is an activity where you have to load the truck in such a way that the center of gravity is at the right place in the center of the truck. This is another one for forklifts. And finally, stock management, which is quite difficult, stock management. If you reorder strawberries when there is no strawberry, you have no strawberry to sell for a few days. Okay, very nice activity, they like it, and I like it as well. So, does it work? Do they learn something? So we made experiments, 20 kids with this tangible, and 20 kids with a multi-touch, like a big iPad. The same software, instead of running with these plastic shelves, it runs with an iPad. And you see they learn more with this tangible thing. 1 cent, made in China. Than with this, you know, very expensive. I like it because everything today is about iPads, you know. iPad is wonderful, and Microsoft Surface and so on. And this is cost-worthy. Why is it better? First, they go faster because, you know, it's easier to move this shelf. When you touch them, you know, you feel, you're not like that trying to move them with your fingers. It's faster. But also, so because it's faster, then they can explore more solutions. And also because you hear them. Or they say, oh, Pierre, no, no, no. Not like that. No, we never put it like that in my company because we have the boss office there. So we don't want to pass in front of the boss office. So they connect this to what they do in the company. They make some link between what they learn at school and what they do in the company. That was the goal. Okay, good. But look at the guy on the left there, you know. Even if it's school technology, if you leave them alone, these guys, you know, they're 18 years old. What do they talk about after a few minutes? They talk about girls and soccer. Soccer and girls. And nobody talked about independence. Okay, so instead of doing a well-controlled experiment, when we put that in the classroom and leave the teacher use them and so on, the results in terms of understanding or problem solving, there is no much difference between these cool tabletops and using paper. Huh. It works well, but still, in the classroom, all the difficulty of the classroom, it doesn't work so well. So we did some activities where you've seen that the system beams information on a sheet of paper. In the class, we have 4 lamps, so 4 teams of 4 students. They copy the values, and then they go to the whiteboard, and the teacher asks them to reflect. Say, okay, why is your warehouse faster than his warehouse? I put more shelves. Very good. But why is yours not so bad? Well, because if you have fewer shelves, you can have wider alleys, so the forklifts can go faster. So the teacher tried them to bring them with him. Just playing is not enough. So this is a proof of what we say. These are 4 groups. The best group on the right, the worst group on the left, and you see the red column is when they manipulate the shelves. The bad teams, they manipulate too much. They play too much. They don't learn because they are just playing with this thing. And if they can play and play and play and learn nothing. It's not because you do a mistake or whatever that you will. No, these guys are not going to stop and say, okay, let's think about why or where Rose was faster. No, they don't care. The teacher would say, will come and say, okay, why is you faster? You were Rose faster than before? Say, we don't know. That's it. So we had to invent things like this one. Okay, whatever. I think it's in my bag. So the teacher comes and put this card. It's forbid the simulation. So they build a warehouse and they cannot run the simulation. So before they build, they run, they build, they run, they build, they run. Okay, here they cannot run the simulation. So they build a warehouse, and when they want to run, they call the teacher. So the teacher comes and he has the key to run the simulation. And he asks to the kid, well, do you think it will be faster this time? Say, well, we don't know. You know, they are teenagers. We don't know. Like that, you know. Okay, so the teacher says, okay, think about it and you call me. You call me when you know. So the teacher goes away and says, monsieur, okay. So, yeah, do you think, yes, it will be faster. Good. Why? We don't know. So I say, call me when you know. So the teacher goes away. And the kids say, well, no, sir, we think it will be faster because we've put more shelves. Okay, that's an hypothesis. Now I show the card, and you can run the simulation. So these are tools that the teacher has in his pocket that allow him to manage the class. And that's the point. You know, sometimes you say, hey, that will be wonderful if we give an iPad to every child in the classroom. That's wonderful for the kid, but the teacher is dead, you know? Imagine you have 20 kids with an iPad and say, hey, guys, hey, oh, guys, I want to explain, hey, I want to, please. No, it's not possible. So here, there is another card called Pause the Class. So, oh, I got that one. Okay, so there are 4 lamps in the class, and if the teacher wants to explain something, all the guys are playing. We are killing the teacher by doing this very sexy technology. So now he has one of these cards, he put the cards, and all the tables become white. All the lamps could become white. Say, okay, I explain you something, he explain, he turn the card, and they can run the simulation. Okay, very simple things, and the goal is that it's a nice technology about collaborative learning, but without the teacher, they will not learn. Okay. They will play, they will learn. It's good for the teacher because he can teach something which was very difficult before. They like it. But we have to design in such a way that we don't make the life of the teacher more difficult, otherwise the teacher is like us. He's a smart guy. If there is something that makes his life more difficult, he does not use it. So, we have also other tools, like this is a beamer that where you have all the teams being projected. And with this kind of orchestration tools, yes, we got significant results. So, and you see the teacher is walking all the day in the class like that with the orchestration cards in his back. Okay, so it works well because of design-based research. So this was not invented by us. We've been working with this teacher over years. They did not invent it either, but by discussing with them all the time, with searching for a solution, at the end we find this nice solution. So now I want to move a bit on the theory side. So basically what we call here, I said this is an orchestration card. What we mean by orchestration is managing the classrooms. Okay, there's kids and so on. And more precisely, we call that a lesson plan. Some people call that a didactic strategy, pedagogical scenario, CSL script. Let's call it an activity graph. And I will explain the other words during my talk. So why is it an activity graph? Because most of the things we do is a sequence of activities that stretch over 3 planes. I mentioned that before. Some of the activities are individual, some are in class, some are in groups. Okay? Every box is an activity, and the links between the activity represent flow of data between these activities. So you can represent a lot of things, like on the top, it's a traditional lecture. On the bottom is these clickers methods from Mazur. The teacher lecture, he stops, then student answers, individual, and then they have to convince the neighbor, which is collaborative, and then the teacher discusses the result of the vote. You know, use clickers and the vote of the student, the answer of the students appear in the PowerPoint. You can describe a lot of activities. So here is one that I use a lot. It's called argue graph. It's an activity to help people to argue with each other. As I mentioned at the beginning, if you leave them alone, they don't argue a lot. How do we make them arguing more? So here, I give them a questionnaire. There is no, that's not a topic I teach, it's just an example, okay? There is no right or wrong answer. There is different answers that reflect different opinion. Like in a large city marathon, if somebody finished the marathon in 4 hours, should we make drug testing against this person? Yes, because it's cheating. Cheating is cheating. Yes, because it's bad for his health. No, because anyway they run for themselves. The ranking do not matter if you run in 4 hours. No, because anyway they have the right to smoke. So why not choosing drugs? So this is not right or wrong. Every student answers 10 questions like that, and then the system makes a graph based on their answers. Whether they are more tolerant or severe with respect to drugs in sport. I know in Spain, you know, if you were severe, there will be no Nadal, no Indurain, no Contador. So you must be on the left. You must be very tolerant. Okay. There is no drugs in sport in Switzerland, of course. And then whether the reason why that is more moral or an health question. So here, 20 students answer to the question, and then the system makes graphs of people with the opposite opinion, and then these people have to answer the same questionnaire again. So it's just a method to create argumentation. If you put them randomly, the students together, they will not argue. If you select carefully, if the system selects for you carefully students with opposite opinion, there will be more fight. And then the teacher does a debriefing. So here, like the teacher in this logistics example we compare on the blackboard, here the teacher has all the answers from the students and he can build a lecture based on that. And I use it a lot for my courses. When I teach pedagogy, this kind of methods, when I do this debriefing lecture, it's a pleasure because the students have been arguing. So during the lecture they say, oh, yes, no, that's not what I meant. So they are with you. You know, sometimes when you lecture and the students are like that, it's not fun. The students it works very well. So the jumping between individual, team and class, this moving works very well. I'm not talking as a researcher, I'm talking as a teacher at university. So, and then they have to write an individual thesis. So, I mentioned 3 levels. Actually, you can define 6 levels. The next level is the periphery of the class, the other people in the school, like the director or the parents who have a stable relationship with the class. Then you have the community, like if you go to visit a museum or a park or a sea, and then you have the rest of the web. And we can have a lot of multiple representation. This is, if you split on the top, if you split the class in 2, half of the class go to do individual exercise and you keep half of the class to do lecture. And so you can see we have a lot of possibilities. You can have loops. So you can say, okay, we have this activity that you repeat n times. And so it's a powerful notation to describe, let's say, rich pedagogical stories or scenario. Even more here. So as I mentioned, the lines between the box represent the data. So remember these argumentation things? The answer from the individual is used to make pairs. So we have to reduce the data produced by the students in one activity to set up the next activity. That's what we call in computer science a workflow. Reuse data from one phase to the second phase. The data from the second phase are reused from the third phase. And we can have different relationship between these activities. I will not go into these details, but we can do a kind of detailed modeling. Are there computer scientists in the room, or you are mostly from education? No, Giannis, you have been computer scientist 20 years ago. Davinia, okay, 1, okay, 2, okay. So I will not go into the details, but we can have this precise description. It's not computer science, it's just going into more detailed description of the flow of data. But basically the strength of a link is, do you really need to complete activity number 2 before to start activity number 3? Sometimes one activity is to motivate the learner, okay? It's important. But if you have no time anymore, then you say, okay, I have to skip that, and okay, I still have, you know, or maybe one activity is one nice example, okay, but sometimes you just have to skip. So some activities cannot be removed, some of them can be removed. That's when you have the strength of a link. The elasticity is how much delay you can have between 2 activities. Like, you see, I told you that in my argumentation things, the students are with me. So we do the fight, and then the lecture, and the student, and between the 2, 1 coffee break. And during the lecture, yeah, the students are with me. And once, instead of doing a coffee break, I say, oh, we do it next week. And on the next week, it was a flop. Say, why did you say B? Did I say B? Don't know. So, you know, sometimes you cannot stretch. If you motivate the guys to learn something, and then you come 6 months later and say, I motivated you. What? You know, okay, so we can have a precise description of this script. Now, these scripts are not only learning activities, and that may be something. In instructional design, we design learning activities, but in the class, there are a lot of other things that are not about learning, and we never talk about it in education. So here we have, the blue box is the learning activity, okay? We design them, and there are some debriefing activities, as I mentioned, this one where the teacher compares the solution. Okay, they are also designed. But then there are a lot of other things in the life of a classroom. Like, when, I don't know you, but when we do experiments on learning squares, we do one lesson on that. But the teacher will do 3 or 4 lessons on square. A first one and then a second one on slightly different. It's not that we teach something once at school. I mean, kids see it several times. Homework. We don't do much technologies about homework, but it's an important part of life. Copy. Kids spend a lot of time copying things in their notebook which were written on the blackboard still, whether it's good or bad, but I mean, it's a lot of time. In a day of, I don't know, 7 hours of class, the real learning time is maybe 1 hour, 2 hours, 3 maximum. The rest is kind of filling activities. And I have a nice example about homework. The students in this logistic activity, they print a sheet of paper. They build a warehouse, they save it. And they save the best warehouse. And at the end of the day, they print a sheet of paper like this, that where the teacher asks them, now go back to your company and compare these warehouses to the one in which you are working. Remember, we managed to, at school, that they connect what they do at school with what they do in the company, and now we want the opposite, that they connect in the company what they've done at school. So at school, they have to bring this and to discuss with their boss. And the teacher from the classroom told us, you are ridiculous, you know, you are academics, you don't know what is a school, you know. You teach at EPFL, the best students, but no, our students never do any homework, never. So don't give them any homework. And 90% of these students did the homework. So the teacher was surprised. And why? Because they were like that. Because we use paper. This is a fantastic invention, paper. Okay? So the teacher, we did not say, oh, there is a website where you can save, and there is a login, and you go with your boss. And no, if the guy say, boss, can I see you 5 minutes on the computer? There's no time. No, but it was a paper, so in their pocket like that. So they go to work at the coffee pause, they say there, hey boss, did you see this? So, and the boss say, hey, what is this? Huh, is it what you do at school, huh? Oh, okay, and you know, it just took 5 seconds to have this discussion with the prof. And 5 seconds is a big difference compared to 5 minutes. So, that's what I call orchestration. When we design activities, for instance, as computer scientists, we think everything should be online. But sometimes, no, okay. These things could be a menu. We could have a menu on the computer of the teacher, but the teacher could go back and quickly put his glasses and quickly find the menu. No, it's so easier to do this. And if the team is very good, you can say, okay, you are very good, I don't need to control you anymore. I'll leave you the card, 50 francs. So, that's orchestration, trying to integrate into design, not only the learning, you see we focus on learning and our teacher, but also the practical things, what we call the logistics of the classroom. And yeah, there are many of the activities, like, I don't know if you've seen, the activities start when the teacher put the sheet of paper on the table. Okay? So he has a binder with all the curriculum, he opens it, he put it, no login, no http/something, /something. And then there are also other things in the classrooms that happen all the time, like that we don't consider in research. Like a child, there is a lesson, a scenario in 3 parts, but we are in part 2, and 2 children were absent in part 1 because they were sick. So how do we handle them? What is the solution? Or we do a teamwork, and then suddenly one of the team members drop out at university level, he abandoned the course. And the 2 other one complain and say there is too much work. So we have, for instance, in another system where teams of 3, if one was missing, we activated a spy button, a spy functionality. If you have teams of 3 roles, okay, you make teams of 3 people, each of them has a role, like you are Vygotsky, you are Piaget, and you are Dimitriadis, okay? And is that okay? 2 beers, huh? Piaget, Vygotsky, Dimitriadis. And then Dimitriadis abandoned the course. And Piaget and Vygotsky complain, hey, we have more work than the others. So what your team will be able to do is to borrow the work because in the classroom we have 10 teams, so there are 10 others, 9 others Dimitriadis. So you can borrow the work of the 9 others Dimitriadis, and in that way the course can go on, we can survive despite this practical problem. So that's orchestration. Can we design technology by taking not only into account learning, but also these little problems of daily life? Okay. So orchestration is a real-time management of activity graph to optimize constraint satisfaction. What is a constraint of a teacher? When you do an activity, what are your constraints? Well, there are some intrinsic constraints. You want the guys to learn, the girls or the boys to learn, okay? And the constraints are who are there, what are the level, how people learn, what do I teach? We don't teach the same, everything the same thing. So you have very specific constraints how to teach, okay? That's one thing, but there is something else, which is extrinsic constraints. How much time do I have? How much time is, I don't know, when you teach, we spend a lot of time, you know. Oh, I have left 5 minutes. If I start a new chapter, no, it's ridiculous. I mean, we are all the time managing time. Control, discipline, you know, we don't talk a lot about that in research, but for a young teacher, the first thing is, will I survive? I have to manage this guy. Huh? If there is too much noise, the director will complain, the parents will complain, and so on and so on. A lot of factors there. Let me give you, this is the one I mentioned, the time. Well, if there is no login with the paper sheets, but we spend 5 minutes, we help the teacher to manage the time. This is one about discipline. You know, you have seen one lamp. There are 2 versions of the same lamp. One of them is not good with teenagers in terms of discipline. If you are teaching to teenagers, one of these 2 lamps, both of them are the same. It's a camera and a projector. But one of them is not very good for this constraint, keeping some level of discipline in my class. The black one or the white one? So the question is, which one makes the teacher's job more difficult in controlling the kids? Who says black? Who says white? Who understands English? Okay, someone almost, did you? Why?
Because it is attractive and the people want to touch it.
The white one is more attractive, okay? You said? Okay. What's the problem with that? Okay, so too attractive, okay. Other problems? Okay. Move what? Okay, yes, you can actually.
Yes, you can move, the children can move.
Okay. Okay, last week I had 20 policemen and they said the white one because of the corner and you can hit yourself on the corner. And actually the left one is not very good with teenagers. Why? Because it's very beautiful, but they are hidden behind it, you know. You don't see them, you know. Maybe they start smoking during the lesson or whatever. You know, as a good teacher, you must, you know, scan you must see everyone. Otherwise, you lose some of them. So it's very physical. So we actually went through a long evolution in the shape of this lamp. Okay, so we have to maximize, the design has to maximum all constraint satisfaction. Also not only learning, but also time, discipline, energy. Should not design something that only the teachers who accept to spend all the Sunday preparing the course will do it, you know. Normal teacher with their own kids and their own activities. So the next thing is to minimize entropy. Let me explain this. When you design an activity, you design an activity A with the hypothesis that it will bring the learner in the state phi. And so the probability that the learner reach the state 5, some cognitive state after having done the activity A is something. Let's call it alpha. There is good chance, let's say that if you do that, you learn that. Okay? And we don't have one activity, but we have a sequence of activity A1, A2, A3 in such a way that there is a good chance that if you succeed A1, you can do A2. If you succeed A2, you can do A3. So very simple model of design. The problem is that this probability that if they do something, they learn something, is a probability. It's never one. Okay? And also a lot of other things happen in the classroom. So let's say, so how much knowledge has a teacher about the state of his learners, how much uncertainty he has about the state of the learner is the entropy of the classroom. Let's imagine you have a learner and he has 3 possible states. In reality you have 3,000, but let's say 3. Okay? The learner can be passive, active, or with me. With me is really the guy who, you know, I can say here, not very accurately, for most of you, who is with me, who is passive, and who is in between. Okay, so let's imagine that I have this probability about John that is probably with me, 0.06. No, active. I don't think he's really with me because he laughs after 2 seconds, while the people with me, they laughed after 1 second. So I can detect who is really with me or not. And then I do something. I've seen my students, and then for a while I write on the blackboard, so I have no more information. So my uncertainty increases. I don't know anymore if John is active. Maybe more chance that he's passive. I don't know. My uncertainty increase. And then I ask my class, is that clear? Okay. And then one student smiles. And he's typing on his iPad. Hey, and you smile. That means he's not with me. Okay, if you listen to me, you type, you know, to my lecture, and you type and smiling, it means you are chatting with her. You know, somebody else. Okay, somebody else is using. Okay, if 2 students smile at the same time, you know what they are doing. Okay, so probably that decrease my entropy because I have a good probability that you are not with me, that you are not active. Then, if somebody says, I say, is that clear? I say, means nothing, okay? I have no clue, so I'm still exactly at the same value as before, okay? And then if somebody say, sir, there is a mistake on the board, on the blackboard, then he's with me, of course. Okay, so every single action that we do, we can have, oh, Yanis is not smiling anymore because I bring information theory, which is his baby. Every time you make an action, you can increase or decrease your certainty about every learner, and globally, how much are you sure that you have the class with you or not? That's only for Yanis. You see, it's almost in Greek. It's in Greek for him. Okay, so actually, there are 3 ways to reason on the state of a learner. One is the probability that is in a state given the fact that it is activity. That's a priori. And then when the lesson unfolds, you can compute the probability that is in a state because he was in another state before. Like if he was with me 1 second ago, there are still chances that he was with me now. There is, if it does not, if all the students, sorry, if another student on the top does not understand anything from my lesson, there are more chances that this student does not understand anything. And if he finds a mistake in my lecture, there is more chance that he has understood my lecture. So you have 3 axes of reducing this entropy, which is the personal consistency, the social consistency, and the inference, or you translate a behavior into a cognitive diagnosis. So there is an attempt, there is still a lot of work to do, to turn this intuition about orchestration into something more formal. Can we count the amount of information of a teacher? So, for instance, we have a model of information theory by Shannon in which you have an emitter and a receiver. So imagine this kid is in your lecture room. He's not snoring, so he's not emitting any signal from Shannon's point of view. But from the teacher point of view, there is a signal there, okay, if you see one sleeping. So the point is that the idea is that every second, the teacher who is looking at the class collects information about the state of the others. And he makes some reasoning. You know, I don't know you, I don't know your name, so I'm not doing a deep reasoning on each of you. But globally, I try to maintain a statistical overview of, but I cannot, you know the cognitive load theory. A human being can handle 7 information at a time, plus or minus 2. Okay, for me it's -2 because I'm from Belgium, so and still, so I need methods. If you are 50, okay, so I need, let's say, for each of you, let's say I have 3 information, attention and so on, and times 50, 3 times 50 every second, because I keep a little bit the history. That's too much information. No human being can handle that. So we have tricks as a teacher to compress this information. Otherwise, we would be in permanent state of cognitive overload. So if that's what I wrote here. Let's imagine that a teacher has a cognitive load of 10. When you teach, you are tired after teaching, because you are, you are teaching, you are monitoring, you are listening, you are thinking, you are doing a lot of things. But still, there is much more information in the classroom than what a teacher can handle. So, that's why we need tools. Let me, because of the teacher model, the fact that the class drift away from the plan, he will have to adapt the activity graph that I mentioned, either by saying, I relax some constraint, like my constraint is time. I still have 10 slides, and there is 1 minute left. What should I do as a teacher? 2 options. One is I stop my plan. I say that will be for next week. One, I say, listen guys, there will be no coffee break today because I want to finish my 10 slides. So I break the constraint. I have I change my plan or I break the constraints. I have these 2 options. For instance, here in the argumentation script I show you, the constraint is that we should have people with opposite opinion. But if you are a university teacher, it's okay. But if you are a primary school teacher, there may be some kids that you don't want to put them together because you know this kid is fragile. Even if you want to do argumentation, you don't want to do it with that kid. She's too fragile and you don't want to take risks. So whatever the constraint is, you should be able to break what has been designed by the designer. And here, so the system was making the group in the argumentation graph, but you could at any point change the group and change any decision by the teacher. So if you want, this is an activity as we presented at the beginning, and we want to do to empower the teacher to make the teacher able to enable the teacher to change these things in real time. So orchestration is about flexibility. How much you design something, this workflow, and how much can you, when something happens in the class, you must change, okay? You must change in the fly because it doesn't work or because something happened, like, I don't know, suddenly it's snow, okay? If it's no, I don't know, that's not a very contextual example. When you at primary school teacher and it's snow, then all the kids say, oh. Or if there is a crane, you know, suddenly a truck arrives and there is some work there and there is a crane which starts operating in front of the window of the classroom. No way, you know. You say, okay, kids, today I need to teach rotation and translation. That's the only thing you can teach because there will be. So you have to adapt all the time. And the nice thing about these cards, about this sheet of paper, is this is not paper. This is a computer interface. With these cards, there are some activities when we use this as to change a value, for instance. This is because of the tags, you can manipulate the data structure of your plan at any time. So that's one of the great thing about paper is that you can change them in any order very quickly in a way which is easier than with computers. So most of the things that we do, there are 3 layers of information on a piece of paper. Some information which is printed, some which is beamed, the augmentation, and some which is handwritten. And here I will show you some examples from primary school now. This is to teach geometry. And the teacher wanted the kids to learn to use a protractor, le rapporteur, this round thing. The real one, not a virtual one. So therefore we use paper as an interface to teach geometry. And you will see how it looks like. So the first activity is very basic. It's learning really the gesture. How do you compute an angle? So here he was asked to make an angle of 70 degrees. He checks, I know it's 69, so he has to try again. And okay, now he got it. And then there is another angle, but it's a red one. Red means you have to use the other side of the rapporteur, of the protractor, the left angle. And here he continued to use the right one, and then he get the complementary angle. And then he doesn't, oh, it's on that side that I have to compute the red angle. That's just how to learn to use a protractor, not very fancy.
Je peux aller à 120. Dans l'autre sens. Dans l'autre sens. Dans l'autre sens. Dans l'autre sens.
The other way around, they say. Dans l'autre sens.
Ouais, tu vas voir. Ouais, je vois. On parie 118. Ah ouais. Voilà, c'est pas 120.
Okay, I go a bit further. There is a more interesting activity. You have satellites around the Earth, and you have to destroy them by shooting a laser. And there you compute the angle for shooting, and then there is a separation, and you give to the other part of the team, you write the value of the angle, and then the direction clockwise or anti-clockwise of the cannon, and then the other team has to shoot. So the first one was just to learn the use of the protractor, and this one is to understand that an angle is a tool of communication. So now the other team has the cannon, the laser gun, and they have to come to measure the angle. They don't see each other, and the separation is quite high. And then to shoot. So they've been shooting, and what we see, oh, they missed. They did not destroy the satellite. So, and why? Because it was accurate, or sometimes because they choose the wrong direction. And the two parts of the team start to shoot at each other. This is a pedagogical scenario that works extremely well in schools. Everything I show you is used in school. Huh? It's not lab demos.
Mais qu'est-ce que tu bouges la feuille? Ça change rien, le bon il revient. Toi qui bouges ça. Mais t'es con, ça change le trait de place. Mais si je bouge la feuille, ça change pas de place. Regarde, le point il revient dessus. Non, pas cette feuille, faut pas bouger cette feuille.
Okay. So here is another activity where we use paper as an interface to teach symmetry. You know, paper it's not only a tool on which you can write. You can rotate, you can cut, you can flip, you can do a lot of geometry teaching with about 10 activities. This one, the kid drew only one, and the system drew the other projection. Here is the same application now to another world, the world of carpenters, where now we're back to vocational education. Carpenters, again, 4 days per week in a company, 1 day per week at school. And they spend 3 years learning to make this kind of 3D drawings, especially to learn to compute the true length of an edge, which is not in any of the three orthogonal plans. So this is what they do. So that's exactly what they have to learn at school. We don't try to change the curriculum. We say, okay, maybe what you are learning, we can teach it in a more effective way. Here is an example of activity where one team plays a block. It seems very easy, but it's not so easy, especially if you take a more complex blocks later on. Save it. And then give the block to another team, which has to find a position, giving only 2 of the 3 orthogonal projection. And then they can, to help finding a solution, they can use the construction lines. That's exactly what they learn at school. Huh? We reproduce on paper what they do in schools. Good. So, I talk about paper, but you have very different kinds of papers. Huh? You have seen sheets, you have cards, you have different types of paper. It's not just one paper, it's a bit richer than that. So, these little tags, if you want, as I mentioned before, they are some kind of handles. They connect the reality of the class with the digital structure that, that you have, which is the lesson plan. And if you want, for any object here, it exists twice. There is this physical object in your hands and the virtual object in the systems. And when you move one in front of a camera, you move the digital object in the system. So this lesson plan that you've designed there, in some way there is a third dimension. It exists in 2 worlds. And by manipulating one world, you manipulate what is in the other world. So this is why I call them handles, because they are places that connect the physical reality with the virtual reality, and by moving them, you change the state of the other. These 3 layers of information on papers have a different time duration, and that brings me to the next point. How do you accumulate information? I mentioned there is too much information for the cognitive load of a teacher. If we think from a theoretical point of view, it's impossible. And so we filter and we keep what we can keep. But can we increase that by aggregating information? On the left, I show you this kind of cockpit that the teacher has when there are 4 teams using this interactive lamp in the classroom. The teacher has a cockpit, some kind of tool that summarizes all the information he needs to know. Okay. So instead of having everything in his head, some of the information is on his cockpit. And that's the same for this tool that I want to explain now. This is now university level. So I talk about teenagers, about kids. Now it's about university students. I would not say adults, but all teenagers. So this is an experiment in my university, which is an elite university. We take 2% of the best Swiss students, okay? And half of them will fail after the first year. And they will fail because of physics and calculus, okay? And in physics, typically, they receive 10 exercises. So a 2 hours lecture, 2 hours exercise. They receive a list of exercises, they start to do them, and after a while, they stop, and they call a teaching assistant. And after a few minutes, they change their hands, and they wait for the teaching assistant. What do they do when they wait? Look at this. Wait a minute. So it's here. So the lady on the top is the teaching assistant, and look at this guy here at the bottom. So Physics 101, the toughest course at EPFL. And there is one guy on the top, he's waiting, but at the same time he's walking. No, this one here is doing nothing. And look where the TA will go. Okay. So she goes to the guy who was doing nothing because the other one is still working. Okay, so so why was he doing nothing? Because he wanted to look at the teaching assistant to grab her as soon as she was available. And we computed how much time they do that. When they wait, they spend 62% of the time doing nothing. 62%, the toughest course of EPFL. This is why Hamed invented this lantern. So the color indicates which exercise you are doing. 1, 2, 3, 4, 5. Why? Because if everybody here, I'm already on 5. If everybody is on 1 and I am on 5, I can wait a little bit. I will have my Nobel Prize later on. Okay, I don't need it. So the number of LEDs tell you how much time I've been working on this exercise. Here, I've been working for a few minutes. Why? Because if I'm here and I need some help, okay, from the very beginning, I just read the question, I call for help. I will never become an engineer. Okay? First, I must try by myself, and then when I tried enough, I can call the teaching assistant. And then, well, that's it. When I need help, I push on it, and it starts blinking. At the beginning, very slowly, and then faster and faster. What's so funny? And so, that's it. I mentioned before 62% wasted time. With this thing, 6%. Okay, very stupid technology. I'm from Belgium, so this is not smart. Okay, you know, this is not. People always want to make smart technology. This is not smart. This is very simple. You gave them, say, okay, you turn when you change exercise and you push when you need help. Okay, you don't need a user guide. And by the way, when the teaching assistant comes, this becomes pink, and again, it shows how much the teaching assistant stays with the team. Because sometimes you have a teaching assistant who stays for 30 minutes with the same team, especially because we are a male campus and there are not many female students. So sometimes if you help a female student, you will stay 20 more minutes than if you... Anyway, so very simple, very stupid, but a wasted time. So here, there is no learning in that. Okay, it's not, you would say, it's not a learning technology. It's not about the pedagogy. It's about, it does not change the pedagogy. It's about the management of the classroom. And still, it makes a big difference in terms of results. And actually, the teacher receives a summary of a lesson, how much time they've been working or waiting and so on. So what is this actually? Back to the information theory, we say the teacher receives too much information. This is a buffer. It aggregates information, and when you look at the class as a teacher, you have this aggregated information for the, so you reduce the cognitive load by aggregating, by buffering information for the teacher. Okay, so that's what I just said, instead of having this huge amount of information. So, one question now. Look at this graph. Did you notice that this picture? Did you notice that the 4 computers? So this is one of the class of logistics, the first system I showed you, this one. And we have 4 lamps in this class. And these 4 lamps have a different color. Will the color of the computers have an impact on learning? Before I showed you that the shape of the computer could have an impact on, let's say, classroom management. Here, you would say, hey, these Swiss people, you know, melted cheese is bad for your brain after too much melted cheese. It's not possible that you believe that the color of the computer plays a role, but it does. Which one? Why would it be good? Why is it easier for the teacher to have 4 computers with 4 different colors? Yanis, you are not allowed to answer. I know that you are smarter than everybody else. No, he just heard my talk a few months ago. So. But he seems to remember something. Yeah? Because the teacher can handle the class. Hey, the red team, the white team, the blue team, and the black team. It's very simple. It's not very smart, again. But just one details that explains something. If you consider the interaction between one person and a computer, this kind of computer, the color has no role. That's the level 1, interaction between one person and the computer. Level 2, interaction between a group of people and the computer. The color plays nothing. Level 3, interaction between the teacher, the whole class, and the computer. Ah, yes, at this level, the color plays a role. So when we talk about human-computer interaction, there is always this individual level, the interaction between a human and a technology. The second level, interaction between a team and a technology. And here, what I want to push in terms of classroom ergonomics, which was the title of the talk, there is something at the class level. For instance, the color has no influence at the class level, at the level 1 and 2, but has an influence at level 3. These things are typical device for the level 3. This thing is a typical device for the level 3. So it's about these 3 circles of usability: the individual, the team, and the class. So that was the notion of classroom ergonomics that I introduced. At level 1, we have design constraints, such as cognitive load. At level 2, you have design constraints, such as what you see is what I see, the fact that the technology has to provide the same view on different users. And at the level 3, you have this idea that we have other constraints at the class level, like time, management, and so on. And I finish by a last example about problems. This is speaking time in a team. 4 people, vertical, time is horizontally, amount of speech is vertically. 4 people in a team, and you see that here there is one guy speaking more than everybody else. And usually in collaborative learning, the guy who speaks more learns more, because he explains, he justifies, he argues, and so on. Not always, but let's say speaking or explaining is a good thing. The guy who says nothing, not always, but very often, will not learn a lot. He's not engaged, he's not involved in discussion. Can we do something to regulate that? Again, it's not the learning itself, it's the management. Can we do a technology that help teams to participate more equally? That's the role of this technology. Here in the middle, this is a table. In the middle, you have a microphone array, 3 microphones, so that my voice will hit that microphone 2 milliseconds before that microphone, so the system can compute the angle of who's speaking. And then in the table you have LEDs, so it's very simple. The more I speak, the more the LEDs turn on. And if I speak too much, I will progressively invade the table territories of the others. This is how it looks like, if I manage to click. It's an older version of the table. He's a French guy. See? So we did experiments where here you have, for instance, the voice of 4 person. Mrs. Blue said, well, I was speaking too much, so I decided to speak a bit less. Mrs. Green says the other way around. I decided to participate. So you see the 3 person at the top tend to equilibrate their participation in the meeting, and except the guy at the bottom, he said, no, I don't want to speak. will not say, probably a Swiss German, but you know, I don't want to speak. It's not because the bloody table wants me to speak that I will speak. So it doesn't force you, it's just a tool for regulation. But when we have many teams, there was a significant effect on the imbalance. The difference of speech between people was reduced by using this table. And we use it in a bank for several months actually, and the imbalance, so the difference between speakers, continued to decrease over time. Okay, here is my point. This is not smart technology, okay? This is not a smart technology. And the table is not a smart technology. So people say, Pierre, what happens if I say blah, 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 blah? Please? Then they say blah, 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 blah. They say, and the table turns on and say, huh, Pierre, this table is stupid. I say, yes. You know, we are fed up of having always smart technology. You know, we try to have very simple things that, you know, do not need any explanation that you can use like that. So we could have an algorithm, an iPhone application instead of this. We could have every student use his iPhone, say, I need help, and the teaching assistant receive the list of all the people waiting in the right order, much more precise. Instead of giving the exact time, we could give the exact time. Here we give some kind of idea of the time. So we reduce the quality of information deliberately. Like the table, we could display the exact speaking time. Now we show these kind of fuzzy things. Sometimes by reducing the quality of information, reducing the resolution of information, you make things more acceptable. If I'm the TA and I have my list, now go to teams number 3, now go to teams number 5, I will not use such a technology. So sometimes the technology has to be kind of modest, not smart, not, you know, in the background. You know, you don't see them at some point. You look at them when you need it. You know, not this kind of gorgeous, things in the background that you tend to forget. So that's my last slide. If you want to design for this classroom ergonomics, there are some principles. One is help the teacher to control things, to be the boss, to be the driver, to decide when you want to stop. Very often as a computer scientist, we tend to take decision instead of the teacher and think the teacher should not change that, which is a big mistake. Visibility, I mentioned that many times, the fact that the teacher can see everything that's happening. When you have all the kids with the iPad, you know, except if you are a very tall teacher, you know, like that, then you can see what they do. I don't even see what you do there. Huh? Is this Ibrahimovic? Okay. So with this, for instance, the teacher can see from quite far away what the kids are doing. Flexibility, give the teacher the possibility to change things in real time. One thing which is I don't know if it's clear for you, is we like to touch, okay? It's not all virtual. You work on virtual learning, but we are not virtual. We are animals, okay? Yeah, we are mix. I'm from Belgium, okay, but we are mix of bones, and we like to touch, we like to manipulate. Some things are great, much better in virtual way, but keeping some physicality. Like here, you know, they just like to push, you know. Yeah, it's just a pleasure. Minimalism is the fact that, well, that's a good example. We put almost. There is almost nothing, like you can push and turn, that's it. Then people say, Pierre, it would be nice if we put a small microphone so we can record the voice level. And maybe if we put a little display, we can choose a few options. There is a little display and a few keys. But you have a microphone, a few keys and a display, you have an iPhone, you have a computer. It's not, you know, you really have to fight. It's like the camera. You know, always you have 200 functionalities that you will never use. We have to fight to keep this minimalism. And the last point that I mentioned is that we should not design for, you know, we all know teachers which are fantastic, some of them, okay? They will spend all the weekend preparing something for us because we do an experience. So we also know teachers which are very bad, okay? But the majority of the teachers are okay. They are not heroic, they are not bad, They just want to do this work correctly, but not to spend the weekend preparing for us. Okay, that's, I have not done all this nice gadget alone. That's the people who have done it. And if you have a master in PhD in computer science and you are looking for a job in a place where we ski in the morning, we sail in the afternoon, we have great wine in the evening, then you can apply to join my lab very quickly. Thank you very much.